In a table tennis tournament, every participant played every other participant exactly once. Although there were twice as many right-handed players as left-handed players, the number of games won by left-handed players was 40% more than the number of games won by right-handed players. There were no ties and no ambidextrous players. What is the total number of games played? Right. First of all, if there are 3n players, the total number of games played should be 3 and choose 2. And that really rules out the possibility that C, D, and E are the correct answers because they are not of the form 3 and choose 2. The first one is 6 choose 2, and second one is 9 choose 2. These work. Secondly, if we use this bit of information for the percent related information, let's say that the right-handed players won WR points. So it should be 1.4 times WR equals WL. When we multiply both sides by 5, we get 7 WR equals 5 WL. And we see that if WR is 5K, then WL is 7K. So the total number of points is 12K, should be divisible by 12, or is a multiple of 12, which rules out the possibility that the correct answer is A. We only are left with B36. So B36 is our answer. This is a fast way of solving the problem. Now let's rigorously show that this has to be 36. I'm going to do it on the next page. So let's assume that there are too many, 2n number of right-handed players, and then there are n number of left-handed players, and then the total games won by right-handed is WR, by left-handed is WL. And we also know that WL, 5WL equals WR, 7WR. So let's write an inequality for WL, upper bound and lower bound for WL and WR, and let's compare them. First of all, let's find the lower bound for WR. So WR is at least as big as, at least 2 and choose 2. Why? Because this is the number of games they played among themselves, and each point is just a point won by a right-handed player. Okay, and then let's find an upper bound for WR. So this is less or equal to than n choose 2 plus, like this is the points coming from the games they play among themselves, and each should be WL. Each left-handed player can get 2n points from the right-handed ones, so they can get in total 2n times n points from the right-handed ones. Okay, and then let's use all three in one inequality. So we get 7 times 2n choose 2. Actually, less or equal to than 7 times WR. This equals 5 times WL. And this is less or equal to than 5 times n choose 2 plus 2n squared. Okay. And this sets a relation, the inequality for n. And let's work it. So the left-hand side is 7 times 2n minus 1 over 2. This is less or equal to 5, parentheses, n minus 1 over 2 plus 2n squared, right? And let's multiply both sides by 2 and expand the left-hand side. So we get left-hand side equals 14n, parentheses 2n minus 1. It's less or equal to then 5n minus 1 plus 20n squared. And then let's cancel out n's from both, and then distribute whatever we need to distribute, and add things up. The left-hand side actually simplifies to 14n squared minus 14. Actually, this is 14n minus 28n minus 14. And then the right-hand side actually is 25n plus 5. Then we get 3n is less or equal to than 9, or n is less or equal to than 3. So this is the first thing that we get. Secondly, as we showed, 3n choose 2 should be a multiple of 12. On the one hand, on the other hand, 3n choose 2 equals 3n minus 1 over 2. If this is a multiple of 12, then this has to be a multiple of 8. Okay, n is less or equal to than 3, and 3n minus 1 is multiple of 8. The only number that works is n equals 3. And when n equals 3, there are 9 players, and in total 9 choose 2 games, which is 36. Which is exactly the number that we figured out earlier. So again, our answer is B.